Good evening, everyone.
Good evening. Good evening, all of you.
Good evening, sir. And warm welcome at IIA. So it is virtual, but you're always welcome at IIA. And before we start, there is a message from Sir Vishweshwarya's family on the tweet, and they are thanking all of us for arranging this conference meta on his birthday. And to start the talk, I just brief about the chairman, sir. Sir Somanath is the Secretary, Department of Space and Chairman of Space Commission. In his previous assignments, he has served as Director of VSSC, Director of LPSC, Associate Director of VSSC, and the Project Director of GSLV Mark III launch vehicle. He is an expert in the area of system engineering of launch vehicles. His contribution in PSLV and GSLV Mark III were in their overall architecture, proposal, stage designs, structure and structural dynamics design, separation systems, vehicle integration and integration procedures and development. He took his BTech in mechanical engineering from TKM College of Engineering, Kollam, and Masters in aerospace engineering from ISC Bangalore, with a specialization in structures, dynamics, and controls. He is a fellow of Indian National Academy of Engineering, fellow of Aeronautical Society of India, Astronautical Society of India, and a member of International Academy of Aeronautics. He has published several papers in journals and seminars in the area of structural dynamics and control, dynamic analysis of separation mechanism, vibration and acoustic testings, launch vehicle design, and launch services management. He has widely traveled as delegate and representative of India in UN Corpus at Vienna, International Astronomical Federation, International Program Committees, International Astronautical Congress held at different countries. He is the Vice President of the International Astronomical Federation, in the charge of the technical activities, and a member of Technical Committee for Space Transportation and International Project Program Management Committee. Good evening, sir, and Happy Engineers Day. The title of the talk for Shri Somanath ji is World of Emerging Space Technology. Over to you, sir.
Thank you. Good evening to all of you. It would have been very nice that I had a glimpse of the people who are sitting there to listen to me. Otherwise, I'll be talking to the board. Of course, that is a fate of any online talk. And I'm really sorry that I am unable to make it in person for the part of being this conference on modern engineering trends in astronomy. And also that today the program is on Engineers Day, and this is a talk with the Engineers Day theme. And all of you are eagerly waiting for my talk to end for the musical program also by the IIA family, and also I hopefully a good dinner, which I missed. And I would like to really say sorry for not being able to travel there and come because of some other pressing official engagements. If you allow me to show me the camera of to move little bit to show the people there, I'll be very happy. Can you take 1 minute to do that?
Sure, sir.
So at least I'll keep the image in mind and then speak. Huh? Okay. Oh, very nice. Nice to see all of you. Thank you so much. Okay, then we can go back to and just show my presentation on the screen. So I just framed a talk, a world of emerging space technology, and also to say what India can do in this domain. So this is what I thought that I should speak. Then I will quickly go through those slides. So there are some 30 slides, but then I won't be dwelling on each of those slides, but I would like to say a few important points because I know that type of people sitting there are more into the domains of observational physics, science, and also people who build instruments and people who have been working on various domains into the astronomy, but also the type of engineering services that you have been doing to build systems, operate systems, and bring out new innovation in all those equipments and measurement systems, and also make good science out of it. I think all you people are there. So for you, and I thought that it must be an inspirational talk for what we people in space sector are doing in terms of engineering complex systems, as well as to look at the world and then see what we should do in India. I think this is what I thought I should speak. But before I speak anything what we do, it is important that to understand what is happening in the global scenario in space sector. There are new actors emerging, building complex launch vehicles and systems, and also disrupting the way the entire space ecosystem has been there safely under the domain of the national space agencies capable of building rockets and satellites, but it is slowly moving to industries and innovators who build reusable rockets and conduct missions for pleasure of going to the crossing the Karaman line. And also we see building of rockets and has also happened to be in the startup ecosystem in India as well. And there are also people talking about moving to Mars and then colonizing them. Possibly this may happen or may not happen, but the type of work going on, this is really very actively going on, and they are getting ready for such ships to be tested in very soon. And also look at the type of communication network happening through the LEO constellations of large number of satellites able to provide the internet services to the common man into his devices directly with the low latency services. So this is the type of changes which are happening. And equally, like communication, there is also remote sensing satellites in large numbers able to provide continuous observation and video streaming capability to your mobile devices. Next slide, please. Now, if you look at India, India has been able to build a certain capability in space ecosystem. It is not only through the developing systems of hardwares, but also creating people all across, and also collaborating with institutions all across the country through the academic centers, incubation centers, space technology centers, doing certain sponsored researches, and also engaging with industries and startups over the way. And today we are happy to see the emergence of the private ecosystem in space, which is really a happy thing to see, that the whole of the space activity is not only confined to the ISRO, but also it is now expanding and new actors are coming, which is really a welcome thing to happen. Now, next. Now, if you look at the technology evolution in the rockets, if you really see, I don't have to explain. I think most of you must be educated very well in terms of the capability that we have, and also the complex machinery that we have built over the years in solid propulsion, liquid propulsion, and cryogenic propulsion. But at the same time, while developing all of this, we have also created a human capital or manpower pool, we can say, in various domains of technology and engineering. So this is the biggest contribution that we have in India. Today, nobody doubts that we can do something in space sector. It's only a question of decision and a question of money. Then anything can be done. Now, this is very well understood. Now we have and the most important challenge for us is to maintain this knowledge base and skills in the people, so that the engineers and scientists today in this organization will be able to spread out the knowledge to other domains like private ecosystem emerging, and then create a multiplying effect. So this is what we look at in the coming days. So I'm not going to explain each of these capability that we have today. Probably you know, rocket building is a multidisciplinary science in which everything and anything that you can talk about are really there. Next. Same is the case with the spacecraft. Spacecraft over the years, we have been improving in terms of its range of services, like the resolution, the spectral capability in terms of the technology, observation capability, also the instruments that goes on board, and also the ability to put spacecrafts to Moon, Mars, etc., etc. And slowly, advanced technology, miniaturization, large antenna, ground infrastructure, low latency processing, all these are coming into the satellite domain. And today we are even talking about satellites in thousands numbers into production mode of satellites. Nowadays, all satellites are one specific satellite. The most important part for our country is that we have been providing these services both in communication, remote sensing, and navigation by national agency. And this is also going to change in the days to come. because new satellite builders, instrument developers are emerging in the private ecosystem, and there are going to be private satellites built in India and launched by Indian launch vehicles for use by private ecosystem, and this is a very big game changer. Next. Now let me quickly dwell on the technology thrust areas in the future on rockets, satellites, applications, and science, and also commerce. The anyway, I am explaining more into this detail, so I won't spend each of these points now. Next. On the rockets, probably you may know that there is a GSLV Mark III which we have developed. We are getting into converting into human rocket, human space flight enabled rocket. We call it human rating, and there is a plan to increase its capacity to almost 6 ton to GTO with the induction of semi-cryogenic technology. Though this is something already in the planned track which is going on. Next. But the one which we are trying to do in the future is more important. I think emergence of rockets which are reusable is something that is disrupted the entire ecosystem of rocket building, because the access to space, the cost has come down from $20,000 per kilogram to LEO to almost 1,000 to 2,000 kilograms, maybe lower also in the market. And this is a very big game changer. And every launch vehicle builder is grappling with this issue. And we also cannot keep silent, and we have to develop new rockets which will be reusable. And this development, we are thinking that we will develop through enabling technologies and also with the private participation. So this is the model. We would like to do this. And already I'm very happy. There is a team started working, and they are already configuring the rocket, what way it should be done, and discussing with industries on production, even before the design. I think this is the change that we are making now. Next. And there are many technologies that goes into this rocket. That some of them which I will discuss in the coming days, which includes recovery, reuse, locksmith and engine, throttleable capability of engines, and also new materials and manufacturing techniques, including additive manufacturing. So this is the type of thing which I would like to discuss today. Next. The vertical takeoff and vertical landing has really transformed the way we look at rockets. And we were earlier calling rockets expendable rockets. Now there are reusable rockets, and we always believed that wings are required for reusability. But then people proved it wrong. And we also have to have this capability, and various ways of achieving this capability are there. One is vertical landing by throttling the engine, and another is by deceleration by aerodynamic means, which we have tested recently, an aerodynamic decelerator. And we also have to prove many technologies, how retropropulsion, throttling of the engine, vision navigation systems, etc. And also create the required infrastructure, of course. So this is already in our plan of action. Next. And we also look at how air breathing can come into this. This is a very complex thing. For example, vehicles which actually use scramjet engine and accelerate itself with a positive thrust is a dream for many people. I think this is something which is used in missiles, but it has not been very successfully used in launch vehicles to give very high accelerations in supersonic regime. Missiles generally use in reasonably high supersonic, but here it goes to hypersonics. And we have successfully tested such an engine long back, but then we are now looking at building a bigger vehicle which will sustain for long duration. The entire engineering has been now completed. Manufacturing also in progress now for test flight soon. I think this is another major development we are working on. Next. Yet another important work is to send a space shuttle-like craft to the orbit so that we can have a payload delivery and bring it back after the mission is completed. So this is called HAVA. This is a hypersonic air vehicle assembly which we are trying to do through the technology which we are developed for RLV. RLV technology, we have done already a demonstration, and we are going to land this now and later develop a vehicle which will fly on top of the GSLV submodule. Here we can deliver at least 300 to 500 kilogram payload in orbit, then spend maybe months together in orbit, come back after certain activities and come and land here. So this is a design for which we are working on. Possibly in another 2 years of time, we will have a prototype ready for testing. So this is very another active work which we are continuing. Next. In the human space flight, probably you know that the Gaganyaan program is on. This is only for the first time flight of the astronauts to space. But then we are looking at how we can take it further and then develop future human spaceflight vehicles where there is a sustained access to space is possible. So here we believe that the GSLV Mark III cannot handle that, and we need to develop a newer vehicle. So earlier we talked about a vehicle which is a reusable vehicle. Its same variant is what is thought about as the future human spaceflight vehicle, where the payload capability can be increased, number of people that can travel can go higher, and possibility of going to higher positions like planetary exploration all are possible. And this work is currently being done under Gaganyaan project program to look at inhabitation module, docking experiments, etc. Currently under proposal stage. Next. Another interesting thing that has recently emerged is space tourism. Probably you know the space tourism is already on. I think people are already booked for travel. In the Virgin Galactic is offering space tourism missions, and probably you know the ticket charges are quite high. It is typically something like 5 crores plus, and for a person to go up and come down, and you will experience few minutes of zero gravity experience, and you will be able to see the Earth from space as a globe, and also experience crossing the Karman line. All that for that price. If you have, you can always travel. But the interesting part is there are many people who are willing to put that money and then travel, because you don't need a huge training, possibly 5 to 10 days of training, and you will be ready for flight. And with extreme high safety standards, they are able to do this. And we are also getting ready with some proposals of this nature, which I will not explain now. But we are also looking at how to develop it through a private-public partnership, and also host some of the already developed tourism activities within India. Of course, the Virgin Galactic is in discussion with us to actually start a facility for onboarding some of their missions in India itself. And we can see that the cost is coming down, and it is not a complex technology today, a rocket technology, but then safety once you built in, all these are possible. So recreation is going to be something which is very interesting business proposition. Next. Another important thing which you should work is on engines. I think all the liquid engines that we have today, we cannot talk about reusability or all these type of exotic things unless we have better engines. So this activity also started in Liquid Propulsion System Center to develop a methane-based LOX methane engine of a 100-ton class, and which can be throttled. And one of the picture which you just see below is the test of a LOX methane engine of subscale class, where they have successfully fired these two combination of these two propellants, which is a very welcome step, and it has to be scaled up to the bigger engine, which they are currently working on. Why this is important is, as far as launch vehicle people are concerned, methane is one of the best fuel that you can ever get, having least problems of coking, and also availability of methane is very high. Even it can be synthesized from hydrogen and water using Peltier reaction. So this is something, not Sabatier reaction, which is something which is very welcome thing for creation of fuel in other heavenly bodies. Next. We also work on various other propulsion technologies called green propulsion and also hybrid propulsion, which is currently going on, where green is a catchword everywhere. If you put green, then you have welcome everywhere. But hybrid propulsion is something which the Virgin Galactic uses, where they are able to throttle engines using liquid oxygen as oxidizer and solid fuel grain, which is paraffin based, I believe. And they are talking about building these rockets here. And recently we have done a test of one of these engines in VSSC on a hybrid rocket engine, and possibly next slide, please. Another domain of our work is electric propulsion. Electric propulsion is very interesting because it provides you one of the. So the electric propulsion is something which is very exciting because of the high specific impulse, and satellites can be of lighter class for the same functionality. So we have started a major program in ISRO to develop all electric propulsion satellites. But it requires huge power to be derived from sun for giving reasonably high thrust. And improving the life of this thruster is one of the engineering challenge for all of us. Especially it has to work very large number of hours, like 30,000 hours, etc., continuously or intermittently without any degradation. So this is a very important materials development challenge, and also to keep the performance very high, both electronics point of view and materials point of view, is one of the biggest challenge that they are faced. And also equally challenging is the interference that this gives to the rest of the electronic systems in satellites. So this is a lot of research work is being done to increase the life, to minimize interference with the rest of the electronics, and also to have higher ISPs through innovative research domains. Next. Nuclear propulsion assumes very importance because slowly when you go into satellites which will have to travel long distances and also to have interplanetary missions, the power cannot come from solar. It has to come from only nuclear energy. And I want to tell you that we have done this beginning and we have now developed a thermoelectric heater, isotope-based heater unit along with the bark. And this will be flying soon in one of our satellites. But what we want to do later is to develop power based on the RTGs, the radio isotope thermoelectric generators, and this work is already started by our propulsion team as well as with the bark. And this is identified as a major task that has to be accomplished in the days to come. Next. And as we engineers know, we have been trained to build parts, design them through the conventional engineering methods, and go to the machines and manufacture them. And this is something which we have been trained. But the additive manufacturing processes which are now come has disrupted the entire approach of building products through conventional approaches of material removal to the non-conventional approach of material addition. And additive manufacturing technology has just emerged. It has still not become a very advanced and professional, but even within that capability, a lot of people have started doing even liquid engines and complex machinery parts using additive manufacturing. And we have created a roadmap for induction of additive manufacturing, especially metal additive manufacturing, into the rocket systems. And many of the parts which you will see in the future will come out of this. And this is a major action. And one of the R&D activity in some of the space centers will be oriented to understand the metal additive manufacturing and improve the technology. Maybe possibly at about 5 to 10 years of time, you will see most of the metal manufacturing will be shifting from conventional metal removal process to metal additive process, giving superior material properties as well as strength and durability. Next. Energy system is another area. Probably you know it is because it is so much prevalent in electric mobility and also your mobile phones. But then batteries and energy storage systems are very, very important in the days to come because it not only for the terrestrial application, but also for space applications and a combined applications in various sectors, including energy storages for a long time. And this has been a very important domain that ISRO continue to work in the chemistry, manufacturing processes, and reduction in cost through innovative methods. For example, lithium is not that easily available. So other material combinations for high energy density production of batteries, including solid state batteries, is some of the hot research topics currently going on. Next. I don't want to talk about materials in general because materials are the key building blocks for anybody, any engineer to build a product. But then conventional materials are well known. Possibly the metallic materials and composites are very well known, but then functional materials are very important for most of the complex systems, which are listed here, including dielectrics, magnetic materials, and optical materials, ceramics. And we have been paying great attention to develop capability within the organization to work on these materials. Some of the advanced ceramic materials for electronic applications are being designed and built here. And also the magnetic materials are, even today, we are dependent on the outside world for support, which has to be indigenized. So is the case of optical materials where low expansion glasses and optical glasses manufacturing. We are starting in a big manner. It's actually today in small scale, it is available at many places, but then building them in large blocks and use in many of the applications is very, very nationally very important. And this is a thrust area. Next. Same is the case with composites. Actually, composites are the building blocks of the future, especially those vehicles that I've shown. But then really the composite design capability exists, but the raw material manufacturing is absent. Some of the advanced manufacturing techniques that we have already brought into ISRO, which is the picture which is shown there, which is simply a fiber placement machine. It is typical of an additive manufacturing machine in composite domain. And this is already there in ISRO. And we have started manufacturing parts using this technique, which is much more versatile than the manual technique of building the complex parts, which I have shown in the bottom. We already capable of designing and manufacturing of the products, but the raw material still comes from outside. So the indigenization of this is taken as a major task within the country, in different stakeholders. Next. Electronics manufacturing, yet another big issue. Probably you would have read enough about the silicon challenge that is open to industries to establish new foundries in India. I believe that this will really help us. But then, meantime, whatever little bit facilities that we have been successful in manufacturing many parts using this and then inject in the space program, including the major processor called Vikram and many other devices and detectors for our program. Thank you. Here next. AI and machine learning is into the space program so much, where this is into different domains. For example, into the intelligence of the vehicle monitoring, mission post assessment, and also in the fault diagnosis and prognosis of various areas like electronic systems, NDT techniques, propellant grains analysis, test data image analysis, etc., etc. So there is a team in every center today to look at AI-enabled tools development for various activities. And anywhere I go, I am seeing this. Any problem are linked to AI. Of course, that maybe it is the initial interest, but then to really create a very good AI tool, it is a real complex process. I believe some useful results will come out of our activities in this domain soon. Next. We also getting into robotics and also using our orbital platform of the POEM, the PSLE Orbital Experimental Module, to test some of these capabilities. One of them is doing a tethered robot and this capture of debris from space, render-one docking applications, and also to put a humanoid simulator for various applications. Here, technologies associated are being developed here, complex engineering problems of motor drives, dynamics of systems, then kinematics or movement of various elements, control algorithm, electronic sensors, all are being developed, and including complex softwares for object identification and manipulation. And all these are one of the very interesting topics which are being currently handled by engineers in ISRO. We also look at various other modes of recovery of objects from space. One of the technology which we have recently tried is the drone net technology, where drones will fly a net and capture falling objects. But the falling objects come at tremendous speeds, and you cannot capture them without breaking the net, unless the speeds of both are matched and you catch it with a reasonable low reaction. For this purpose, we have now developing aerodynamic decelerators to slow down objects which are falling, so that we will be able to capture it using these technologies, so that possibly we will be able to adapt it for future recovery of low mass, low inertia objects from space. Next. The space application side are emerging new complex demands are coming, where the satellites are becoming more intelligent. The delivery of data from satellites are becoming more demanding in terms of the high throughput, which we are already there, and also streaming of data for devices and facilities, institutions becomes very important. And we are also looking at satellites, which will become very important tool for security, surveillance, and space force. And so they are going to become slowly an integral part of the life of everybody. And one example is going to be the drone. We are studying how drones can be very usefully deployed with the support of space technology. Today, when drones are deployed, there is a complex problem of monitoring, piloting, and then reaching it at the right places by appropriate drone pilots and without causing traffic hazards. So how can we enable space technology to handle this is a question which we are currently discussing, which is not an easy task because of the two-way communication requirements. And we need to enable both of satellites and drones to be communicating each other, so that we can have a integrated transport arrangement for meeting all these demands, including strategic as well as civilian sectors. Next. And in the communication sector in satellites area, there are a lot of disruptive technologies coming, which includes the constellations of the non-GSO constellations, and also high throughput for single aperture terminals, the flexible software-defined radio payloads, which are already there, and many other things, which I don't want to go through. And here we are looking at how we can adapt some of these inputs into our satellite design for the future. And currently the priorities are there for already satellites which are currently being built, which are massive and heavy. But then we also have to look at how communication satellites can be put in low Earth orbit for low latency applications and in large numbers. This is how to operate it economically for a country. This is a big challenge in which we will have to do a lot of design iterations to arrive at a proper solution. Next. In this type of satellites, even though we do LEO constellation studies for satellites, the geo satellites will never be extinct because they are country specific, they are location specific. But then slowly the orbital resources will be very short supply, and we will be having to put satellites at available slots. So hence the demand for flexible payloads, which will reconfigure based on the location demands, and also frequencies and beam coverage can be software driven, which will give a lot of advantage for operators and users to get the best out of the satellite in a given situation. So this is the new norm which we are trying to understand and then develop. Already some satellites of this nature are already in space, but then ISRO cannot lag behind, and we will work on this to come out with a solution soon, especially when you are having high throughput demands increasing day by day. Next. Same is the case with the navigation. Navigation satellites, probably you know that there are 7 satellites which are put to the NAVIC, and some of them are not working. Still, we are able to provide the services, and we need to keep the GSO constellation of the NAVIC for the regional navigation services or NAVIC active. But then there are questions on it, how we can remain it, whether this much of coverage is enough, whether we need to extend it to a global coverage. These are being addressed now. And we have reasonably concluded that we need to have a combination of GEO, MEO constellation to be maintained for giving services within this country, and possibly expand it to a global constellation at a later point in time with lesser expenses. So this is another challenge for us. Next. And for data from space, like the Earth observation, there are a lot of applications, civilian to strategic, and there are a lot of technologies which are giving strength to this capability, which includes better cameras, more software-driven approaches, onboard processing and intelligence, compact payloads which have high agility, the propulsion system, and also to be better, and constellation-based inter-satellite communication capability, improved revisit, etc., becomes important for mission point of view. So when you have such large Earth observation constellations, the applications domain today cannot be the ground-based. It will be ground-based, ground-free type of support which we have to give. And this is a big challenge for the designers of satellites of Earth observation. Next. We are into the quantum technologies. Already there are certain research work being done in various centers of ISRO, and they have already demonstrated some low distance communication in optical domain, and successful quantum technology demonstrations have been done. And we would like to have a satellite soon for quantum key distribution from orbit. And this is one payload which we are engineering for demonstration purpose for its performance in space. Next. And there are many technologies which will aid finally the future scientific exploration. For example, one of them which I believe in terms of engineering is a radioisotope thermoelectric generator, which I already mentioned. And unless you have this, you will never be able to think of experiments which will last for longer years, such as the lightweight, long distance, very distant exploration missions, etc. The robotic technology is something which will help us to do many more experiments. Actually, today in India, we are not very much into it, though we do not have a very demonstrated capability in space. And this we have to very urgently do. Combined with AI and autonomy, only going to be the next best step for various scientific missions. Of course, if you look at Chandrayaan 2, or you have some active experiments where there will be movements, drives, and drilling, etc. But these are one level of robotics. I think you need to go to the next level. Of course, our rover is also a robot in that sense, but then we need to develop much more complex systems. Planetary sample return is identified as one of the important goals in the next few years from now. So here again, a lot of development and activities are currently conceived as R&D activities in centers. The small satellite constellation is very important even for scientific missions. I have explained some of the small satellite constellations for example, for the Earth observation communication, but even for measurements from space, including the space weather, aeronomy, and even for astronomy, we can look at how small satellite swarms and constellations can really be configured to develop and derive some capability for observation. And science instruments, of course, is very, very important. And the ability to develop much smaller, compact science instruments is the key to provide in small satellite platforms. See that today, the science missions and experiments which ISRO has conceived are most of them are ending up with very high cost. And we continuously receive criticisms for spending this much of money for certain achieving certain publications and not really showing any tangible outcome or benefit from the views of those policymakers. Of course, this is a question which we can discuss, but then it is always important that we look at how we can look at how science can be done frugally, low cost, and much more efficient way through better engineering of instruments. I'm really happy that I could I am really happy that I could really see some of the laboratories coming out with exciting instruments in many places. And I want to congratulate the community, especially into this domain, to work out more and more, to spend time more and more on instrumentation work, which will be happy to host in some of the upcoming scientific missions and future scientific missions of ISRO. So with this, let me close my presentation and thank you. I believe that the world of emerging space technology is reasonably well explained to you, and how ISRO wants to make use of whatever is emerging outside and what we can do within our resources, satisfying the nation, the government, and the decision makers, and also propose certain advanced technologies for the benefit of all of us. Thank you so much for the patient listening, and I believe that I have stuck to the time. Thank you.
Thank you, sir, for a wonderful talk, and it keeps us a message that we keep on learning to build the new technologies so that we can grow in the area of space also, and for the science which comes out of the space. Thanks a lot, sir, for a wonderful talk. Sir, would you like to take a few questions?
Yeah, if there are questions, of course.
Good evening, sir. My name is Alok Shukla, and my question is about the Gaganyaan mission. So, as we know, the current development for the human mission is going along with our Indian Air Force, and we have the trained pilots from there, and then they are getting trained further for the human spaceflight mission. So, maybe not in a couple of years, but in future, are we having any possibility or any plans to allow civilians to apply for the aeronauts maybe in the future, and if so, then maybe by then?
The answer is yes. And the answer, if it has to happen, then we have to have a program that goes beyond Gaganyaan. Today, the government has approved only Gaganyaan, which is a limited scope of human space flight program. So unless we demonstrate that it is possible for us to do that, we will not be in a position to go for further approvals. And once you approvals means you have to have a longer sustained human spaceflight program of the government of India. And in that, definitely scientists, civilians who will be able to work will come. And finally, we have to ask this question, why at all we are going up there? What is the purpose of going, sending some people into the space and bring them back? This question has to be very clearly answered. And what is the specific interest of India in sending these people? It is not for show that we are going to do this. So we are actually trying to figure out and how to formulate the whole policy of human space flight program. Of course, the first mission of Gaganyaan is simply for a demonstration purpose. That is, with the available technology in India, Indians are capable of sending a person to orbit and bring them back. This is the limited extent of capability demonstration for us. And of course, there will be some scientific goals in this, which is not the primary goal. But if the moment you talk about sustained human spaceflight program, there are various questions to be answered. And I am sure that we can always justify telling that the demand for humans to fly is a very scientific thing. And in the emerging area, the space manufacturing space medicine, high-end technology development, etc., has to happen in zero-G conditions in space, and movement of people back and forth to space habitats in space is essential for any nation to prosper in this domain. So we need to bring out a narrative which will keep us sustainable in this. In that model, there will be everybody, including you, can also fly.
Thanks for answers.
One more question, please.
Sir, good evening. I am Pradeep Chakraborty from Aryavat Research Institute, that is Nainital. I want to ask you a question that as a mechanical engineer, how would you explain the space science or space technology? It's a relation, correlation, important.
Yeah, it is not mechanical engineering or electronics engineering or chemical engineering. Okay, engineering is a method of. I understand on an engineer's day. I think all of us understand. Engineering is nothing but given a problem, find a solution. So the role of an engineer is limited to that much. As a mechanical engineer, I came into this and I have understood it is no longer a mechanical engineer's domain. It is a domain of a very complex interdisciplinary process. So, of course, once you understand one domain, you can learn every other domain. I don't think that there is a compartmentalization. I can also understand electronics. There is no difficulty for it. So, it is an interplay, as we know, even satellite or launch vehicle or applications, an interplay of a lot of technologies. So we look at only like that, and engineers do play a very important role in the overall conceptualization, system engineering, and making of space systems. So that we should support and hail them for their momentous achievements, for converting ideas into products. Thank you.
Thank you, sir.
Sir, I have one question about satellite-based internet. So similar to Starlink, is ISRO planning to launch group of satellites for commercial internet?
No, it is a question of what is the business model that you are looking at. If you want to launch satellite internet services, it is possible for anybody to do. ISRO also can do. But then we are not an internet service provider. You have to understand that. The ISRO is a space agency doing such activities. You wouldn't have heard about NASA having a internet satellite services, or even ESA having internet satellite services. It is a business model. What does OneWeb is doing or Starlink is doing is a business model. It is not a agency work. So there is a difference between these two. And all this can be done only in a commercial scale because it is a global activity. When you build 1,000 or 2,000 satellites and operate, internet service has to be provided to every corner of the world. And it's a global operation, not a national operation. So if ISRO wants to build some satellites and then provide an internet service across the globe, we have to be a global operator, which we are not. So what we look at is how the satellite services can provide to India specific problems we try to solve. So that's what I discussed, that for India, it is geostationary satellites are the best suited because it covers the Indian subcontinent very well. And it gives services to all of us. And internet service is given by our satellites already. You don't know. You don't need Starlink to get internet in your home. Satellite internet service are possible, but it's a high latency service. It's not a low latency service. Now the question is, can we provide a LEO, MEO, GEO combination to give a low latency service? You understand what you mean by low latency service, no? Because the distance involved are 36 into 2. So correspondingly, there is a small time delay for bidirectional communication. If you're simply looking at streaming video, it is there today. From satellite, you can directly receive. There is no issue. But if you want to do bidirectional communication, there is an issue. So we have to look at solutions of that nature. How, with a minimal LEO GEO combination, we should be able to do bidirectional communication and provide internet service. This is what I described earlier in my presentation.
What is the status of ISS part of India and if and how about the from where we are procuring these space suits and what is the status of that project when it comes to space suits? And I heard one manufacturer is there. Recently we made an exhibition center of Bangalore.
I'm not able to understand your first part of the question. Can you ask the question in one sentence?
ISS. What is the status of ISS?
I do not know because we are not part of ISS.
So we want to be part of that, right?
Sir, he is asking what is the plan of ISRO to be a part of ISS? Am I right?
Yeah.
No, I didn't get the question. Once again, can you tell the question? I didn't get the
He is asking what is the plan of ISRO to be a part of ISS?
No, that is a policy question. Are we discussing such things here?
Sorry. Yeah.
Yeah, so what is the status about these space suits, procurement of space suits from India, like from abroad?
No, that is also not a question that we should discuss here. You don't have to ask me status of ISRO many activities. That will I am not ready to discuss those things. If you can discuss any question related to my presentations, I am very happy to do. But don't ask me the status of various activities that is going on here.
Okay.
So no more questions. So we'll just give a big thanks to the sir to give the time for
Thank you. Thank you so much. And once again, I am sorry for not being able to present there. Hope to meet you all of soon some other time. Thank you.
Sure, sir.
Bye. Thank you.